This is the University of Otago.
David Hood from IT Training here, looking at the kind of settings you would use for creating a publication quality graph in R. For this demonstration, I am just using R rather than RStudio, so I'm not just selecting commands and pressing the run button in the script window in RStudio. I am saving the files, saving the commands to a file and running them with a source command. The other pre-assumption I'll make is that I have, for instance, used a web browser to find the R reference card 2.0, and I've looked through that reference card and seen that there are commands like tiff and lines and various other things that I look into for plotting and similar kinds of things. And I've used the R's help to read up the details of those commands and the options for dealing with them. Now, the example data that I'm working with in this session is from the flag referendum. I've embedded a CSV file inside the script. So I've got a column of the electorate, a column of the percentage vote for a change in the flag, and a figure I'm calling flag engagement, which is the interest in the flag relative to the interest in the general election. So it's kind of three columns embedded in the data for all the electorates, and then I read those in. I have picked out some electorates of interest because I have foreknowledge about the results in this, so I have identified the Maori electorates and the South Auckland electorates, and I have predefined some subsets based on those. So a saved subset of the Maori electorates, a saved subset of the South Auckland electorates, and a saved subset of the electorates that are not Maori or South Auckland ones. I have also created a quadratic line of best fit, a bendy one, and I've done that by just for the general electorates that aren't Maori or South Auckland, defining a whole sequence of points within the range of those electorates' flag engagement. I have generated squares and cubes of the flag engagement figure and put them all together to make a model. I've checked the model results, and with an R squared of 0.22 it's a pretty horrible line, but I can describe that in the text of the thing that I'm writing up. I have then generated predicted Y point prediction data based on that sequence of flag points, and I have then generated Y points with upper and lower confidence intervals for the range of the line of best fit. I should add, I'm not expecting people to be reading from the screen from this. I'm expecting you to be listening and watching to it and have the code that should be accompanying the presentation actually open and looking at them in detail. For making the graphs, I'm assuming that it needs particular fonts and axis details for publication, that we are allowed to use colour, that it needs to be 300 dots per inch, rather than, for instance, a vector PDF file, and that the figure has a text caption under it, so we're not putting a main title on the graph. Now, I make an initial plot of flag engagement on the horizontal scale versus the vote for change on the vertical scale. And what that all looks like, if I run that command, and I find the output window is something like that. So that is an in-R graphics window, and I could save it, but then that's not at the right dots per inch resolution for high quality, and trying to scale it, it's going to get pretty horrible. So I'm going to take another route and start building up a better flag. Going back to my script, I'll swap out graph 1 with graph 2. In this version of the script, I am saving it directly as a TIFF by opening a connection to a TIFF, just like I could open a connection to a PNG file or a PDF or a number of other things. And I'm putting in settings like the file name, the width of the image, the height of the image, the units that I'm talking about for the width and height, the resolution in dots per inch or pixels per inch, and the base point size of the text in the figure. So I'm declaring the size of my canvas, I'm making the same plot as before, and then I'm declaring that I'm finished writing to the file, which is actually a pretty important thing to do. And if I run that file, it doesn't actually do anything in R because it saved the graphics window out of it, but if I go and I look at that plot, I now have a TIFF file that is, well, the same at the moment, allowing for a slightly different shaped window. Going back to R and building up the graph a bit more, I now want to do some actual work on the axis and the labelling of the axis and things like that. So the third version of the graph includes the code from the second version, the TIFF file, but the plot has a few more things in it. Switching off the box around it, putting a label on the x-axis, putting a label on the y-axis, setting an actual size for the y-axis, setting an actual size for the x-axis. And with all of those inside of the plot statement, if I rerun that code and I have a look at the TIFF window, well, you can see nicer labelled axis, the box around the outside is gone, and the axis size has changed subtly. So we're step-by-stepping it. And if I step-by-step a few more things and make it a bit more interesting by using colours for the different subsets in my data, this time I'm doing the basic plot, but I am only doing it on the general electorates. So I've got subsets in for the x and y coordinates, both of them, or I'll get an error from only subsetting one of them. And then I'm using a separate points command to only plot the subset of the Māori electorates, and I am changing the symbol that I am plotting with and the colours that I am plotting with compared to what I used for the main plot command. Similarly, for the South Auckland electorates, once again I'm using a separate points command, and I've chosen a separate symbol and in fact size and colour for the symbol points. And once again I will jump over to the console window and run the same R file and show you that one of the reasons that I was using colour with 4 parts, and I'll show you what I'm talking about there, is that so I can get the semi-overlapping points, because it's a bit more obvious where there is a thick cluster. It's not obvious if you use solid points. What I was talking about for that is the way the colours, I'm using a particular form of hash mark, amount of red, amount of green, amount of blue, and amount of see-through. Now I could just be using colour names, but by using this particular form it makes it easy to access the opacity values, how solid the colours look. And these ones are, let's say, 40% solid colours. Now if I jump over to the script again and tackle version 5, in version 5 I am putting on a line of best fit and that confidence interval for the line. Now I've introduced a little bit of extra calculation here, because if you are drawing a polygon, a shape, you're essentially tracing around the edge. So the best fit area, I'm tracing around the edge of it, and that means I have to go forwards through the sequence of points and then come back again along the bottom, or at least the top, come back along the top by reversing those sequence of points. So I put them both together as a list, and similarly for the y points to go along with those x points, I go along the lower confidence interval bounds of the calculated points and then the upper confidence interval bounds. So, same creation of a TIFF, same basic plotting, same points for the Maori electorates, same points for the South Auckland electorates, but then I put a polygon that is kind of in off bluish colour, purplish bluish colour, on by tracing around the poly X and poly Y coordinates, no border, just to fill colour, and I draw a line of best fit through the middle based on the calculated points. So, save that, run my source file again and have a look at the TIFF, and you can see the polygon shape, confidence interval and the line of best fit over the top. So I'm just gradually building it up. Pausing for a moment just to highlight that one of the things with base plotting is the way you do things and then you just keep building on top of what you've done, and that builds up the graph step by step. Now I decide in adding things step by step it would be a really good idea to include a legend, which is just adding a legend command to the previous code. The legend command includes the text of the legend, it includes the colours to make the legend bits and the shapes to make the legend bits, the symbols in the legends, and other things like should there be a box around it, how big do I want the symbols to be, those kind of things. 1, 2, 3, 4, whoops, I missed a comma there, I'll fix that right now. And I save that and I source that, and I decide there that wasn't such a good plan, because in putting things you can see the way the legend has come in on top of the data. I need to do something to fix that, so what I do is I'm going to extend the total size of the graph and I'm going to split the legend into two. Just jump back to the code I'm working with and clear out the old one. So, in extending the size of the graph, in the plot command it's now going further up than it was before, 80 rather than 60, and it's going further to the left than it was before, -0.2 rather than 0. In terms of splitting the legend, I've now just got two legend commands, one in the top left, one in the top right. And if I source that file and have a look at my new TIFF, I can see things potentially finish there. I might want to contemplate my life and decide actually the figure overall should be a taller figure full stop, and then I reset the height and the TIFF and I fit everything else in around it. But for today we'll assume that was good enough and press on. Next thing I am doing is, oops, just clear some of those out so I can keep track of myself. Slightly subtle this time. I decide that the confidence interval should probably go behind everything else on the page. And to achieve that effect, I make the TIFF as normal, I make the plot, but the plot is now set to type N. Don't plot anything. Just set up the axis in the plot area. So even though I accidentally almost left the points in, they're not going to do anything because it's set to no, don't bother plotting it. I've also lost the lim settings, the axis limit settings, because I'm not plotting anything, I'm just effectively giving the corner points. -2, 0 on the x, y, 0 on the y, 1 on the x, 80 on the y, of the graph, and it's going to sort out the area from that as being the bottom left and top right corners. Then I'm putting the polygon down. Then on top of the polygon, I'm putting the points, general points, then the Marie electric points, then the South Auckland electric points. Then I'm putting the line of best fit, then I'm putting the two legends. So I save it, I click in, I source it, and it's an incredibly subtle change, but it just makes the colours of the General Electric circles a little bit more consistent. Okay, well, having messed around with the axis to fit the legends in, I'm actually going to customise the axes a bit over what they were initially. So, take it. So in customising the axis, the plot is now saying don't bother with a y-axis, don't bother with an x-axis. And I'm using custom axis commands further down. X-axis to set up the bottom axis, at being where to put the tick marks on the bottom axis. I zero for line width because I don't actually want the line along the edge of the graph. And then various things about the kind of ticks and how big should the axis symbols be and how should they be fit on in relation to which way round the axis is, things like that. So main thing, I've switched off axis in the general plots and I have put in my own custom axes as part of building up this script. Save and source, and much more minimalistic graph. Still not really convinced about the vertical axis. I would probably actually redo the figure, bringing the axis up. I would look at changing the margins of the figure. That's not a setting I'm going into in this one, but it is something you can mess around with. One final example. I decide, for reasons only known to myself, that papyrus should be a good core font for the figure. I'm really just doing this to show you changing fonts, and there are a couple of different places I could be adding this kind of setting, but I'm putting it in the basic plot command. I'm adding family papyrus for that core information. If you are using Windows, you will probably need to look at the extra fonts package for getting access to the full fonts on your computer, and there'll be a link in the accompanying material that you should probably have a look at for that. So special case for Windows users, but if I save that and once again run my script, well, my TIFF file has its papyratic glory, and that figure is now in theory ready for sending off as a 300 DPI figure. I do want to stress that if it had allowed PDFs, then everything would be nice and vectorized, and I would just be saving as a PDF rather than a TIFF. But this shows a whole bunch of graph making settings.
This is the University of Otago.